solving simple trig equations. We're doing the same thing again tomorrow. The instructions on our handout, it says to solve for x on the interval where x is between 0 and 2 pi inclusive. So looking at this interval is in what format? Yeah, this is in radians. So if it's in radians in the instructions, then definitely that means your answer needs to be in radians. And since our answers need to be in radians, make sure your calculator is already in radian mode. So you do have to have a calculator today. So make sure right now that your calculator is in radian mode. Okay, for problem 1. Problem 1, we have sine of x equals square root of 3 over 2. So we need to find the angles x whose sine value is square root of 3 over 2. First of all, I need to determine how many answers will I have. First of all, how many quadrants have a sine value that's positive? 2. And which quadrants would that be? Quadrants 1 and quadrants 2. And what angle, what's the reference angle that has a sine value of square root of 3 over 2? 60 degrees, also known as pi over 3. Now, let me just make a little diagram over here. So I know 60 degrees is going to be right here. So here is my first angle, angle 1, and we know that's going to be a 60-degree angle. But we also said in which other quadrant would the sine also be positive? Quadrant 2. So in quadrant 2, I'm going to have my terminal side. So back to angle 1, my reference angle is how many degrees? 60 degrees. So here's my reference angle over here, which is 60 degrees. But when I'm trying to find this angle, it's actually going to be from the initial side on the positive x-axis to the terminal side. And I know that this is 0 degrees, this is pi, or 180 degrees, so how would I find the missing angle? I know this entire piece is how many degrees? 180, and I know my reference angle over here is 60 degrees. 180 minus 60. We need to be able to do this on the easy problem. So it's 180 minus 60 degrees to get us 120 degrees. So when we write our answers, remember, they gave us the interval in radians, so my answer needs to be in radians. So that first angle was 60 degrees, which would be pi over 3. This second angle, I'm going to call it x2. x2 is 180 minus 60, which would be 120. And what's 120 in radians? 2 pi over 3. So 1 pi over 3 and 2 pi over 3 are the two solutions for number 1. Next one, number 2, we have the cotangent of x is equal to the negative square root of 3. Now, if you have one of the reciprocal functions, you'll need to go ahead and change it to terms of sine, cosine, or tangent. So if we're given cotangent, we need to change it to tangent. So tangent of x is equal to, if I made this negative square root of 3 over 1, then this would be 1 over negative square root of 3. Is that good? What do I need to do? Multiply both the numerator and denominator by the square root of 3 so that it becomes rationalized. And this would be square root of 3 in the numerator, negative 3 in the denominator. Now, notice my tangent value is negative. So in which quadrants would tangent be negative? 2 and 4. So I need to have two answers here. One answer needs to be in quadrant 2. One answer needs to terminate in quadrant 4. So first I have to figure out, well, what is the reference angle? Is 30 or 60? Which one? 30 degrees. So in quadrant 2, the reference angle would be 30 degrees, but we want this entire angle. So this is x1, and this would be 180 minus 30, which would be 150 degrees. And what is 150 degrees in radians? 5 pi over 6. Now for x2, my second angle is also going to have the same reference angle. What's our reference angle here? 30 degrees. So in quadrant 4, I need a reference angle of 30 degrees. And we need to find this entire angle, which is x2. So how would I find that one? 360 minus 30, which would be 330 degrees. And what is 330 degrees in radians? 11 pi over 6. So 5 pi over 6, 11 pi over 6. Next one, number 3. We have the sine of x is equal to 0.8191. Now 0.8191, is that a value off of our unit circle? No. So if it's not a value off of the unit circle, we'll have to use a calculator to approximate it. And when we're approximating these on the calculator, we'll round to 3 decimal places. So remember, this is the arc sine value. So since that's the arc sine value, make sure in the calculator you type in second sine. So second sine. When you type second sine, this will pop up. Sine to the negative 1 power. And then type in 0.8191 in the parentheses. And we'll round to 3 decimal places. 0.960. We'll try to figure out what that 0.960 represents in just a minute. But notice my sine value is positive. So in which quadrants is the sine going to be positive? 1 and 2. So I need 2 answers here. Well, I know in radians this is 0. This is pi. And what is pi approximately? 3.14. And up here at 90 degrees, this is pi over 2. And that would be 3.14 divided by 2, which would be approximately what? 1.57. So if this is my angle in radians, 0.960 would terminate in which quadrant? Quadrant 1. So here's x1, which is 0.960. So there's my first answer. But I also have to have the second answer. And we said that sine is also positive in quadrant 2. So now we have to figure out what is this angle, x2. Yeah, this would also be my reference angle here, is also 0.960. And I know that this entire 2 quadrants, quadrant 1 and quadrant 2, is 180 degrees, which is equal to pi. So to solve for x2 is just going to be pi minus the reference angle, 0.960. And we'll use the rounded answer. So what is pi minus 0.960 approximately? So x2 is approximately 2.18. And I know 2.18 is going to be between 1.57 and 3.14, which would land in quadrant 2. Next one. Number 4, we have cotangent. Again, if you have one of these reciprocal functions, go ahead and change it to sine, cosine, or tangent. So for cotangent, we need to change it to tangent. And the main reason is because do we have a cotangent button on the calculator? No, we don't. So that's why we have to have it in terms of tangent. Now, if I make this over 1, that means the tangent of x is equal to 1 over negative 1.280. Now, this is the arctan value. So make sure when you're typing it in the calculator, you do second tangent. And when you type second tangent, you need to type in 1 divided by negative 1.280. You said negative 0.663? Okay. We'll talk about what that means in just a second. I want to draw a diagram first. Now, notice my tangent value is negative. So in which quadrants would the tangent be negative? Quadrant 2 as well as quadrant 4. Well, negative 0.663. Now remember, when you do second tangent, you're actually getting the angle. So if your angle measure is negative, what does that tell you about the rotation? It was clockwise. So here's still the initial side, but we went clockwise down negative 0.663 radians. Now technically that's my first answer. Technically I could say x1 is equal to negative 0.663. That is my angle in quadrant 4, because then we wanted the tangent to be negative, which would occur in either quadrant 2 or 4, so we needed both answers. So here's the answer for the first one in quadrant 4. But look back at the directions. What do the directions say? It needs to be between 0 and 2 pi. So if my answer for x is negative, is a negative number going to be between 0 and 6.28 approximately? No, so you can't leave it as that negative. So now we have to figure out what is the positive rotation. So really I need to figure out what is that angle? What's the positive angle? How would I find that? Yeah, we actually need to do 2 pi minus 0.663. I know one entire revolution is 2 pi. Just subtract off the reference angle. So what's 2 pi minus 0.663? 5.62. We agree? So again, make sure your answers are between 0 and 2 pi. I'm sorry, what was the answer? 5.62? Okay. You have to have both answers. You have to have an answer in quadrant 4. You need to also have an answer in quadrant 2. But this is the answer for quadrant 4. We can't leave the negative 0.663 because is that between 0 to 2 pi? No. But that was the value we got from the calculator. I'm just pointing out that that was not the correct answer because it needs to be a value between 0 and 2 pi. So instead of having the negative rotation, we got the positive rotation. It's the positive rotation that needs to be the answer. And that's just for quadrant 4. Now we have to find what the angle would be in quadrant 2. So in quadrant 2, it would terminate right here. And how would I find the measure for angle x2? Well, first of all, right down here, what is this reference angle? 0.663. So how would I find the measure for angle x2? Yeah, for x2, it's going to be pi minus 0.663. And that would be approximately what? 2.48. That's it? 2.486. 2.479? Okay. 2.4, oh, you're ahead of me, okay. 2.479. Okay, so make sure you have your answers for quadrants quadrants 4 and 2. Next one, problem number 5. Now, remember, those of you who are here Thursday and Friday, we talked about when you are solving these equations, you have to get the trig by itself. So what would be the first step to get cosine by itself? Subtract 9 to both sides. So that gives us 3 cosine of x is equal to 7 minus 9, negative 2. Divide both sides by 3. Cosine of x is equal to negative 2/3. Now, negative 2/3, is that a value off of the unit circle? No, it's not. So if it's not a value off the unit circle, that's when you have to put in the calculator. So this is an arc cosine value, so make sure you do second cosine. And we need negative 2 divided by 3 in the parentheses. And round to 3 decimal places, what do you get? 2.301. 2.301. Now, let's figure out what does the 2.301 mean. Well, first of all, our cosine value is negative. So in which quadrants is cosine negative? 2 and 3. So 2.301, which quadrant would that fall in? 2. 2.301 would be somewhere over here. So there's x1, 2.301. Now we need to find x2. Let me go ahead and box that in so it's official. Now for x2, it's going to terminate in quadrant 3. So here's x2. Do I know what this reference angle is? .301 is that obtuse angle. But is this part right here obtuse? No. It's this angle over here. I'm going to call this theta reference. That's my reference angle. So the first thing we have to do, we have to figure out what is the measure of that acute angle right there so that we know what it would be down here. So for that reference angle, how would I find this reference angle? Yeah, this linear pair is 180 degrees, which is pi. So we need to do pi minus 2.301. So our reference angle is approximately what? .841. So that means this guy over here is .841. So right here is also approximately .841. So how would I find the entire measure for x2? Yeah. It's going to be pi plus that reference angle, which is .841. And what would that be to 3 decimal places? 3.983. We need to make sure we're focusing. 3.983. Next problem. Number 6, get the trig by itself. So what would be the first step to get the cotangent by itself? Add 5 to both sides. So 4 times the cotangent of x is equal to 5. What do I do next? Divide both sides by 4. So that gives me the cotangent of x is equal to 5/4. Cotangent, we don't have a button for cotangent on the calculator, so convert it to tangent. So that would be the tangent of x is equal to 4/5. And that's an arctan value, so make sure you do second tangent. And round to 3 decimal places, and what do you get? 0.675. Okay, so now we have to figure out what does the 0.675 mean. Where is it? Well, first of all, tangent is positive in which quadrant? 1 and 3. Well, 0.675, where would that fall? Quadrant 1. So that's x1. Now to find x2, we said x2 terminates in quadrant 3. What would this reference angle be down here? 0.675. So how would I find the entire measure of angle x2? Pi plus 0.675. 1.6 or 7? 1.7. Okay, 3.817. Okay, number 7. Again, get the trig by itself. What would be the first step? Add 1 to both sides. So that would be 3 times the secant of x divided by 5 is equal to 1. Next step, what would I do? Yeah, I could multiply both sides by 5/3. So the 5's cancel, 3's cancel, that gives me secant of x is equal to 5/3. Do I have a secant button on the calculator? So I have to change this to cosine, and what would the cosine of x be? 3/5. I want you to go ahead and finish that problem. This is the easy part. I want you to do the more challenging part, but it's still not that challenging. Okay, so again, they gave us an arc cosine value, so make sure you did second cosine in the calculator. And what did you get? 0.927. Now let's figure out what does the 0.927 mean. Well, 0.927 would terminate in which quadrant? So that's our first angle. I need one more answer. In which other quadrant is cosine positive? Quadrant 4. I'll go ahead and draw a new diagram. So here's x2. What would this reference angle have to be? 0.927. So how would I find angle x2? Yeah, 2 pi minus 0.927. And that is approximately what? 5.356. Okay, moving on to the last section. The instructions say to find the functional values of x. I think yesterday on the handout, I know at least for the assignment, it talked about principal values. Yeah, so principal values, functional values means the same thing. So if you just see the different terms, it just means the same thing. Now the first thing we need to do is first go ahead and get the trig by itself. Now what would be the first step to get secant by itself? Add 1 to both sides. So that would be 1/2 times the secant of x is equal to 1. And I heard multiply both sides by 2. So that gives us secant of x is equal to 2. Instead of secant, I need to convert that to cosine. So that's 2 over 1, so this would be 1/2. Now for the principal values or for the functional values. Now first of all, we have to figure out, or just not figure out, we have to recall from yesterday, what are the intervals where sine, cosine, and tangent are functional? Well, for sine is functional from what to what? Negative 90 degrees to positive 90 degrees. Talked about that yesterday. So negative pi over 2 to positive pi over 2. And what's the other trig function that has that same interval? Tangent. Tangent, its functional interval is also negative pi over 2 to positive pi over 2. But cosine is the oddball. And what's the interval for cosine? 0 to 180, so 0 to pi. Okay, so now, back to where we left off. We need to find the angle whose cosine is 1/2. Well, what's the reference angle? 60 degrees. Now, I need all of the multiples of 60 degrees that would fall between 0 and pi. Well, definitely 60 degrees is between 0 and pi. You agree? What else? 120. So 60 degrees, 120 degrees. Now, my answers have to be, here does it say radians? No, but if we put them in radians, what's 60 degrees in radians? Pi over 3, 2 pi over 3. So if it doesn't specify, you can use either one. Next one, number 9. Get the trig by itself. What would be our first step for problem 9? Add square root of 2 to both sides. So that would be 2 cosine of x is equal to square root of 2. Divide both sides by 2. We get cosine of x is equal to square root of 2 over 2. And what's the reference angle that has a cosine value of square root of 2 over 2? 45 degrees. So we need all increments of 45 degrees, or not all increments, but we want all angles that have a reference angle of 45 degrees. But if I'm talking about cosine, again, it has to be between 0 and pi. So what would be my first answer? 45 degrees, which is pi over 4, and 135 degrees as well. And 135 degrees would be 3 pi over 4. So again, make sure if it's cosine principal values, it's just angles between 0 and 180 degrees. Next one, number 10, what would I do first? Divide both sides by 3.